Hello everyone. My name is Aditya and today we will be starting to discuss the physics paper of 27th June slot 1. So the first question, I'll start right away. The first question, it says that helium and carbon have same kinetic energy and we want to find the ratio of de Broglie wavelengths. Now, students, de Broglie wavelength is defined as h, which is the Planck's constant upon p, and p can be written as root 2 mass into kinetic energy. So, if kinetic energies are constant, lambda 1 upon lambda 2 is equal to root of m2 upon inverse proportional to the square root of masses. So students, the molecular mass of carbon is 12, of helium is 4. So M2 is 12, M1 is 4, so you get lambda 1 by lambda 2 as 12 by 4, which is so this is the first question. Simple inverse ratio to the square root. Now we'll do the second question. I hope it's fine. Uh, Second question. So there is a capacitor. Capacitor is defined by two plates separated by some distance having opposite charges. There is a particle in between which experiences some force of 10 Newton or 20 Newton. Now, if one plate is removed, so if I draw the free body diagram of a particle between the capacitor, so there is a force due to this positive plate which is away from the plate F, and there is a force towards the negative plate which is towards the plate. So F plus F, 2F, FP, FP. So total force is 2 into force by each plate. So if I remove one plate, what do I get? I just get FP as F by 2. My new force is F by 2, which is 20 by 2, which is 10. Simple question. Two plates 20, one plate 10. Simple. Third question. Yes, so this is a question by Young's double slit experiment. The question says that there is a double slit separated by some distance from the screen. Now this screen is placed at some distance d. The difference between the slits is small d. And what it says is the first dark fringe appears in front of one of the slits. So first dark fringe. This is the central bright fringe, this is the dark fringe, then a bright fringe again. So this distance is W. In the Young's double slit experiment, it is equidistant, so this is W by 2. This is D by 2. So the equation here is W by 2, fringe width by 2 is equal to D by 2, which explains W equal to D. Now fringe width is lambda D upon T from Young's double slit experiment. So what do you get? D is equal to lambda D upon D. So lambda, we want to find lambda, I guess. Yes, so it is D square upon D. Now plug in the values which are given here. D, small d is how much? 0.6 mm. 0.6 into 10 power minus 3 square upon 80 centimeter, which is 0.8. So this will be somewhere around 4.5 into 10 power minus. From the options, you can check it's option number 1. Okay. Now, Question number 4. Question number 4. It says there is a lithium 2 positive ion, and if we draw the energy diagram of the same using the Ritz formula, if we draw the energy diagram, so there is a nice trick over here. If it is hydrogen, we know that the difference from n equal to 1 to n equal to 2 is 10.2 electron volt. If the atomic number increases by 1, so if this is a helium positive ion, the same difference is for n equal to 2 to n equal to 4. If it is for lithium, n equal to 3 to n equal to 6, and which can be proven very easily over here. So the energy difference is 13.6 Z square 1 by N1 square minus 1 by N2 square. So for hydrogen, it is from n equal to 1 to 2. If we add Z square, we get 1 upon N1 by Z whole square minus 1 upon N2 by Z whole square. So if we want 10.2 for lithium with Z equal to 3, so this whole thing has to be 1. So N1 equal to 3 and N2 equal to 6. Now we have been asked the change in angular momentum, delta MVR, which will be delta N H by 2 pi. How much is delta N? It is 3, so 3H by 2 pi. So that is your answer. Question number 4, option number 3. Alright. For question number 5, so there is a person running. So when it is standing on the ground, it sees the rain come at an angle 45 degrees. Now let this vector be V rain with respect to ground. Now when it starts running, V man with respect to ground, when it is 15 root 2, it sees the rain appearing vertical. So this is V rain with respect to man, which we have to find. So drawing this on a vector diagram, relative, V relative is V1 minus V2 vectors. So V rain with respect to man is V rain with respect to ground minus V man with respect to ground. Right. So V rain with respect to ground is some angle, I don't know. This is 45 degrees. V rain with respect to ground. V man with respect to ground is forward. So if I have to subtract, it will be backwards. So okay, 45 forward. So this is how it would look. This is V man with respect to ground. This is V rain with respect to ground. And the VRM is vertical. That's what it means. So this magnitude is 15 root 2. This angle is 45 degrees. So for this vector to exist, even exist, we would need a component of this cancelling this one. So 15 root 2 is equal to VRG upon root 2. So VRG magnitude is 30. This is 30. Now I want VRM. So this is one component, 45 degree. VRM is VRG sine 45. Now cos 45 is cos 45, which is 15 root 2. Option number 4. Number 4. All right. Now, question number 6. The question number 6 has some ambiguity to it. If so, I'll solve it for both the cases. If the source is sound, the source is sound, and simple Doppler effect f prime is equal to v plus vo upon v into f, which is 6 by 5 f, because v0 is v by 5, and what we would get is 1.2 times f. So the increment is 20%. Now, if the source is light, light, the apparent frequency formula is a little different. One plus v0 by v upon 1 minus v0 by v into, what do we get here is 1 plus 1 by 5, 1 minus 1 by 5 into f, which is 6 by 4, 3 by 2, root of 1.5 f is 1.22 f, roughly 22%. Both the cases. Okay, so question number 7. Question number 7 says, okay, so there is a capacitor, which has a capacitance of 50 picofarad, voltage of 100 volts. Okay. So this is a capacitor, let's say. Now it is fully charged, so the charge on it will be CV, which is 15 to 5000 picocoulombs. Now it is connected to an uncharged capacitor, so there will be a charge flow, and they will come to a ground state only when the charges become equal. So Q prime on both the capacitors is Q by 2. Now, which is 2500. So initial energy U initial is half CV square. U final is Q prime square by 2C into 2. So half CV square is half 50 to 10 power 4, 2500 picojoules, and this will be Q prime square 25 square by 5 into 100. So this is 1250 picojoules. So delta U is 1250 picojoules. You can check it that the option should be some 1.25 10 power 7. Right. Excellent. Okay. Yes, I can increase the font size. I will. Fine. So, in question number 8. So, the question here, there is a liquid and there is a block kept. Mass is mass is 400 kg. Draw a bigger diagram. 400 kg. Uh, Area is 0.5 meters square. Okay, and there is a slit here, smaller area, 10 power minus 3 meters square. The height of the liquid column is 40 centimeters. Height of the liquid column is 40 centimeters, and you have to find the velocity of the liquid with which it oozes out. So this is point number 1. This is point number 2. Applying a Bernoulli's equation. Bernoulli. This is the son Bernoulli, Daniel Bernoulli's equation. So the pressure at this point is P0 plus mg 400 g upon A 0.5. So this is the pressure. This is the pressure element, and rho gh, which is 0.4. And here it is just the velocity element, half rho v plus atmosphere pressure. Okay, then there is water. So 400, 4,000, this is 8,000, 10, 10, 4, 10, 10,000, 4, half of 500 v square. So you can see quite evidently v square is equal to 12,000 by 500 over 3 over 4. Over 24. Square of velocity is 24. Okay. Question number 9. Number 9. I is equal to 5 sine 120 T. Okay, so I becomes I max at T by 4. T is equal to T by 4. T is 2 pi by omega. For any sinusoidal function, the omega is 120 pi. T is 2 pi upon 120 1 by 60. So the T is T by 4, which is 1 by 240. Simple. Comparing the equation to the sinusoidal function will give you the answer. Question number 10. So the question number 10. Again, a sinusoidal equation x is equal to a sine omega t. So x becomes a by 2 at t equal to 3 seconds. We have to find the time periods. So a by 2 is the amplitude sine 3 omega. Okay. So 1 by 2 is sine 3 omega. Pi by 6 is 3 omega. Omega is pi by 18. Omega is pi by 18. Okay. Time period is 2 pi upon omega, which is 36 seconds. Question number. So this is almost half your people done now. At least the objective part. Question number 11. So there are two blocks here. 8 kg, 2 kg, mu is equal to 0.5. Now if I apply a force here, F, what should be the maximum force for no slipping? It's one of the most basic questions which are done in friction. So in this case, if there is no slipping, both bodies move together. This is very important. Move together. Now, to make them move together, there is only one external force, which is friction, which is the external force which we are applying. Friction is an internal force between the two. So F is equal to 2 plus 8 into acceleration. So you get F is equal to 10A. Now drawing the free body diagram of 2 kg block. The only force here is friction. Friction's maximum value is mu mg. Now, what do we get? Mu, which is 0.5, m is 2, g is 10, is equal to mass 2 into acceleration. This is the only force which can accelerate it. So acceleration comes out to be 5 meter per second squared. So force is 10 into 5, which is 50. If we make it 51, the body will slip. Question number 12. Okay, so there is resistance, there is a bulb, and there is an AC source. Power rating is 25 volt, 5 watt. Now, I max into the bulb can be 5 by 25 because power is V into I, which is zero point 0.2. Now, the I that goes here is zero point 0.2 I max. Now, it comes from this AC source at 200. 200 is equal to zero point 0.2 into R plus the resistance here can be V square by so P V square by P. This is 1000 R plus V is 25 P. R is equal to 1000 minus 125. It's okay. So done for the 12th question. The answer is 875. 13th is a bit calculative. There is a way of doing it. So here we will not just solve it for the whole value. We'll try some calculation trick over here. 13. Now we have the ideal gas law. PV is equal to M upon M average, which is the molecular mass into R into T. Okay. Now the volume is The volume is 2000 centimeter cube P 10 power 5 2 into 10 power minus 3 M 0.76 grams mf. R into T 8.314 into 3. Okay, so this is 2200. So this is 2 by 3 is equal to 0.76 into 8.314 on average. M average is 1.5, so this is 1.14 into 8.314, which is somewhere near to 10, approximately. It is somewhere near to 10. Now from the options, now molecular weight of oxygen is 32. Molecular weight of hydrogen is 2. Now, in what ratio should we mix it to get somewhere near 10? So, 10 is equal to 2 plus 32 into x upon 1 plus x. 10x, 22x, O2 to N2, so this is 2x. So O2 to and H2 2x. ठीक है 2x. If x comes out to be 3. Approximately equal to 3. It's easily provable. 10 plus 10x, 32 plus 2x. So 8x equal to 22. X is approximately 2.9, which is so it is 1:3. Okay. Oh, 14th is an interesting question. At terminal velocity for any ball, the net force is zero. So uh, there is gravity, there is buoyant force, and then there is viscous force. Therefore, Fv is equal to mg minus buoyant force. Now, mg is v into d1 into g, and Fb is v into d2 into g. Therefore, Fb is mg into d2 upon d1. As simple as that. So F viscous comes out to be mg into 1 minus d2 upon d1. 15th, Carnot engine. So Carnot engine source, T source. T source is 800 Kelvin. T sink is 200 Kelvin. So efficiency is immediately 1 minus 1 by 4, which is 0.75. Now, efficiency is nothing but heat absorbed, heat released. And there is some work done. So efficiency is work done upon heat absorbed. Alright, so work done is Q absorbed minus Q released. So Q absorbed 1 minus eta Q released upon 1 minus eta. So Q released कितना है 12,000 1 minus 0.75, which is equal to 48,000. Okay, so the projectile, question number 16. Projectile is fired at a velocity 20 meter per second at an angle alpha. So after 10 seconds, it is here, it makes an angle beta. Okay. So we want to find some beta in terms of alpha, tan beta. Tan beta equal to. So let's say this is Vx, this is Vy. So Vx is constant with respect to time. So let's say this is V0, V0. So Vx will be constant as to 20 cos alpha. Vy initial is 20 sine alpha. Vy at t equal to 10 is 20 sine alpha minus gt, which is 100. Now tan beta equal to Vy at 10 upon Vx, which is 20 sine alpha minus 100 upon 20 cos 2. Option number 2. Seventeenth. So in communications, there is a chapter called, and there is a formula to RH. R is the radius of the Earth plus 2R. So this is nothing but 2R into 5 plus 7, 12 root 2R. 12, 1, 2, 8, 0, 3. So 6480. 4, 1280, 1 to 12 root 1280 is 256 into 5, 5 into 256 into 10 power 2, 16, 12, 192 root 5. Okay. Okay. So this is a question which involves circular motion and momentum. So the mass of the bob is 50 grams and there is a bullet of 75 grams which strikes it at a speed v and it emerges out at a speed v by 3. Now this this can complete a whole circle. So the v here is root 5 r. So the length of the pendulum which has been given is 2 meters. So the velocity which with it goes v1. So using momentum conservation, 50 into v1, which is 5 into 2 into 10, which is the final momentum, into 75 v by 3 is equal to 75 v. So 10 500 is equal to 75 into 2 by 3 v. 25. So D is equal to 10 meter per second. Okay, question number 19. Question number 19. Two blocks of 10 kg and 30 kg. So this has been shifted by x equal to 6 centimeters. How much should this be shifted to this side so that the center of mass does not shift? So this is m1 x1 minus m2 x2 is equal to 0. Therefore 10 into 6 is equal to x into 30. X is 2 centimeters. Left. This is left. Okay. Question number 20. So UV rays for greenhouse, we know that. X-ray, crystal structure, of course. William D. Bragg, William H. Bragg. X is for crystal. So what do we know? B is 4 and C is 3. B4C3. Option number B3. I think there is some B4. Okay, microwaves. Microwave is used in sterilizing. So D2 and A should be radar. Microwaves is used in radar, I guess. Okay, radar is more correct. And E can be used in sterilizing. So this should be the answer for the same. Question number 21. So the light ray is incident at an angle double of refraction. Okay. R to R. So mu is root 2n sine 2r on sine r. Okay. So this is 2 cos r. Simply. So root n by 2 cos r. R is cos inverse root of n by 2. So instead twice of that. Cos inverse root of n by 2. Question number 21 is done. Question number 22. Question number 22. Cell is shorted with resistance of 8 ohm. Okay. ठीक है 8 ohm. So let's say this is V, which is some 3x proportional. In the second case, shortened with 4, potential differences. Okay. Now let the EMF be E, internal resistance be R. Potential difference in this case should be, so V is 8 into E upon 8 plus R, which is equal to 3x. And in this case, it is 4 into E upon 4 plus R, which is 2x. So 8E upon 8 plus R upon 4E upon 4 plus R is equal to 3 by 2. This is 2. 8 plus 2R upon 8 plus R is equal to 3 by 2. 16 plus 4R is equal to 24 plus 3R. Which is 8 is equal to R. So the internal resistance is 8. This is the last question according to the memory based papers we have. So there is a logic circuit in which the input is two cycles up, two cycles down. Input A, input B is somewhere half cycle. And output is 1.5 cycle. So when it is 1, 1, 1, 0, 0, 0, 0, 0, 1, 0, 0, 1, so 1, 1, 1, 1, 1, 1, 1, 1, 1, 0, 1, 0, 1, 0, 0, 0, 0, 0. This is an AND gate. Okay. This concludes the slot 1 paper. Stay tuned for more. We will be doing many such sessions now. My name is Aditya again, and I would really like to know how you felt. Like, share, and subscribe.